I'm going to introduce Fran and Mahir from LF, as well as the other hats that they wear across the industry. But over to you guys. Just forward with the old ticker.
Thank you. Can you need that? Good morning, everybody. So very quickly from me, just for a little bit of continuity, 10 weeks ago in Melbourne, fantastic event, and this is equally fantastic. We presented Linux Foundation Broadband's VOLTHA solution and how it's transforming broadband deployments through open and disaggregated access networks. I think the trick here, don't get too close to the microphone. And at the time, as well as the benefits where we are, status in industry, we covered a number of AI use cases. And my friend Mahir is going to cover that in more detail. So that will be the end of me. Mahir is the Director of Technology and Innovation at Netsia. He's also subject matter expert in telecom networks and network transformation. So he's suitably qualified for the topic that we have at hand. Mahir, please.
Thank you, Fran, for the nice introduction. So let's, first of all, thank you, BBF, for the opportunity to present here. Try to find the hot spot. Okay, so I'm going to present about a white paper recently published by LF Broadband. So let's start with a few short words about the LF Broadband. The LF Broadband Directed Fund was established in late 2023 as an independent fund under the Linux Foundation. LF Broadband supports a collection of projects, including SEBA reference design and open source VOLTHA projects, which are in deployment in Türk Telekom, Deutsche Telekom, and more. So the core thesis of our white paper is the openness, observability, and the programmability is the foundation of the AI in broadband networks. So a useful broadband AI for us does not start with the model. It starts with the operational foundation, an open architecture, trusted observability, and programmable control. Fixed broadband operators, they already have rich data and complex networks and high-value operational workflows. But if the data is fragmented, the interfaces are proprietary, and the control points are inconsistent, AI will remain difficult to deploy and hard to trust. An operator can have really powerful model, but if the network is fragmented, closed, and difficult to observe, then that model will struggle to produce trustable operational outcomes. The network must be open enough to expose meaningful telemetry and interfaces, and it must be observable enough for the operator to trust the data like alarms, metrics, topology, logs, inventory, and service context. And it must be programmable enough to support bounded actions through deterministic APIs, policy, rollback, and audits. So the practical path is not AI first, it is foundation first. An open, observable, programmable infrastructure is what turns AI from demonstration to something that operators can deploy in real production. So LF Broadband's role is to help create this open foundation that helps AI to be practical in this multi-vendor, multi-technology access networks. Now let us look at why this matters for operators now. It's not just because the AI is the technology trend of the moment. The fixed broadband operators are under simultaneous technical and economic pressure. The fiber expansion, the XGS-PON expansion continues, but the capital discipline is very strong still. operators want to, invest and expand their capacity selectively, where investments create the most impact. The broadband access is not only the provisioning and the monitoring of the physical devices anymore. It's more software-driven, cloud-native, and distributed environment now. There are, the access, the CP, Wi-Fi, OSS, BSS systems. They all generate a lot of signals, but they are not always easy to interpret together. The operational discipline is also strong. While expanding, operators want to get faster troubleshooting and better automation. Customer experience expectations are also increasing. Subscriber may simply say that its internet is slow, but the reason may cause, from the access, from the Wi-Fi, or configuration, or service policy anywhere. A multi-domain correlation is essential for better customer experience now. So in this complexity, AI becomes attractive because the gap between the data that operators collect and the ones that the teams interpret quickly enough is increasing, and AI can help to close this gap. So this brings us the two-way relationship between AI and networks. Probably all of you very familiar with these two motions, AI for networks and networks for AI. The AI for networks is using AI to improve how networks are planned, operated, assured, and remediated. Networks for AI, on the other hand, means making networks and architecture environments ready for future AI workloads and agentic workflows. For fixed broadband, the near-term opportunity is mostly AI for networks. We can use AI to improve assurance, troubleshooting, lifecycle management, and planning and operations. But the second motion still matters. The same foundation that helps us operate our networks better also prepare broadband networks for future AI-driven services and workloads. The shared foundation, it's open interfaces, structures, observability, deterministic execution, standards alignments, and open source collaboration, we believe. To make that real, we need to look at the access network environments currently AI must operate in. The broadband access network is not a clean lab environment. So operators deploy GPON, XGS-PON, multi-technologies, sometimes DOCSIS, fiber, fixed access. And they have a complex, in-home Wi-Fi system that they need to manage. They have different devices, from different vendors for OLTs, ONTs, and CPs. And sometimes they have siloed software stacks that they need to manage these devices. They have both brownfield and greenfield deployments together. And they connect a lot of different frameworks and tools like controllers, OSS, BSS systems, inventory, assurance, etc. So all these complex platforms, stacks, frameworks, they create a lot of different signals and data. This mainly creates two problems. First, the human operator, they face too many signals, too many tools and workflows they need to work with. And it's hard to troubleshoot. It's hard to find the root cause and hard to plan capacity, etc. Secondly, the AI systems face the same fragmentation. But the AI systems, they cannot create the consistency themselves. They also need the consistency. They need a consistent data, consistent interfaces, and the reusable abstraction of the network. So when we talk about AI in broadband, we must talk about architecture also. this is exactly where LF architecture, LF broadband architecture, becomes relevant. So LF broadband's VOLTHA and SEBA projects, they help create the architecture condition that AI needs. In its southbound layer, there are devices from different technologies and different vendors, like combo XGS-PON, GPON devices from different vendors. And all these are implemented in adaptation layer of the VOLTHA. And on top of it, VOLTHA provides a vendor agnostic PON abstraction. On top of VOLTHA, the SEBA architecture, it provides the SDN access and SDN management and control capabilities, and exposing normalized APIs for policy, topology, telemetry, and control. This enables AI systems to interact with access network with clean, open, reusable, vendor agnostic and technology agnostic interfaces. For AI-driven operations, this architecture is critical because use cases like predictive analysis for fault detection, predictive fault detection, service assurance, planning, NOC copilots, they all need reliable telemetry, topology, and control context. If every vendor environment requires a completely bespoke integration, AI applications will not scale. The LF Broadband Foundation helps make this telemetry, topology, and control reusable across all vendors and technologies. So I also need to highlight another thing here. That the VOLTHA SEBA also promotes the white box OLT, which means the open hardware. We as industry believe that AI will move from central office or clouds to the edges, and moving access networks, moving the AI to the edges, means moving AI on the edge sides or even on the OLTs and ONTs as well. So this open hardware interfaces makes it enable to deploy AI models, AI workloads, and applications on devices easily as well. So that is why the open and programmable access is not only a network architecture issue, but it's also an AI readiness issue. And on the other hand, why open source is essential in broadband networks? Because AI must work across heterogeneous net environments. Vendor neutrality matters because analytics and automation becomes more reusable when they do not have to be rebuilt for every vendor implementation. Open source also accelerates the collaboration. The operators, vendors, and implementers, they turn the shared needs into working code. They test it, improve it, and validate it in realistic deployments. This helps with the trust that AI needs. And open source also supports the auditability. As AI moves closer to the operations, operators need to inspect the behavior. They need to validate the implementations and understand how decisions are translated into actions. Saying that, we also need to highlight that open source works best when it is linked to standards. The rights model is the standards define the language and the requirements, and the open source helps make those requirements deployable faster. This is the flywheel we need to strengthen as industry. Standard bodies such as Broadband Forum, they define requirements, architecture, interfaces, data models, and interoperability. On the other hand, open source communities, they build the deployable code. implementations, and it actually gets the lower integration risk, the better interoperability, reusable AI apps, and faster path from concepts to production. So the goal is not opportunities in use case are the use cases with high operator value and manageable implementation complexity. The predictive fault detection and root cause analysis are strong candidates because operator already collects many relevant alarms, counters, and optical metrics. The service assurance and subscriber experience scoring are also attractive because they connect network signals to customer outcomes for better customer experience. The service assurance, sorry, I lost the track. So no copilots are other practical near-term use cases. They have low risk, but strong impact of product on productivity. The capacity planning and digital twin analysis are also valuable. They often require broader integration with topology, inventory, and traffic. The closed loop optimization and autonomous multi-domain operations, they are most important in longer term because they require stronger guardrails, stronger governance, and trust. So the lesson is start bounded, prove value, then expand. The path through the autonomy is, in long-term direction towards more autonomous networks, but we should be careful not to overstate the current state of the broadband networks and also broadband network operators. The sensible path is incremental and operator controlled. We start with manual operations. We start with manual operations. So operator monitors the dashboard. It investigates issues manually and take actions according to some runbooks manually. Then the next is AI assisted systems. So AI analyzes data and generates insights. It detects the patterns and anomaly, like the use cases like predictive fault detection and root cause analysis. Then AI recommends remediation workflows and the user approves it. And then after that, operator may allow for policy-bounded automation, but with guardrails, strong guardrails. Then the high automation may come. These guardrails are policies, permissions, deterministic interfaces, rollbacks, audits, etc. So human role does not disappear. It changes from manually analyzing every signal to supervise, approve, and improve bounded automation. This is how broadband AI can become trustworthy by earning confidence step by step. Let me close by returning to the core message. So AI will matter in fixed broadband because operations matter. The most valuable use cases are practical, detect fault sooner, resolve issues faster, improve subscriber experience, and plan investments smarter. But the foundations matters more than the hype. The open, observable, and programmable infrastructure is what allows AI to move from concept to production. And LF Broadband here helps operator and industry build that foundation through open source collaboration, operator-driven implementations, and alignment with standards. The future of the broadband AI will not be determined by models sophisticated alone. It will be determined by whether we invest in open source, the shared architectures and standard alignments. So the practical strategy is clear. Build open foundation first. Saying that, join us on the journey, support LF Broadband to build the foundation of AI in fixed broadband access. And I left here the QR codes for you to download the white paper, the whole white paper. Thank you very much.
You have some extra time. No, your extra time. No, now, because Tiffany asked me to seamlessly add an extra couple of minutes discussion, so nobody knows that we're changing presentations behind. Yeah. No. So, sorry, did I give the game away there? Sorry, yeah. Now, I've known SEBA and VOLTHA now for, goodness me, more than 10 years. How does it need to evolve, or does it need to evolve to an AI autonomous network at all?
So I think it needs to evolve. All these systems, not only VOLTHA itself, needs to evolve in a few ways. So as I tried to state it in my presentation as well, so we need, for AI, we need more, observable systems. So they will probably, all these systems will evolve to provide more and deep observability to the AI systems or other operational systems as well. And I think they will get closer to the northbound systems like orchestrator systems, etc., for AI to, assist for multi-domain operations, I guess. And they will be more close to the standard bodies to give more clean and reusable interfaces and open interfaces, because that is what AI needs to operate better, I think. So VOLTHA and SEBA projects as well, like the other, tools and frameworks and whatever you say, needs to, evolve in this direction to adapt to AI workloads, I guess.
Okay.
Again, thank you.
How seamless was that? Yeah.
Yeah, Manuel, part of DT. Wake up call. No, just wanted to add in that since it's a great question, Craig, actually, right? So what does need to happen specifically in the implementation? So it's a production grade implementation and open source code available. So I think the key thing Mahir has emphasized, and that is also I think what the project pretty much drives over there at Linux Foundation is there are those open APIs implemented available as a reference. So that's where previous talks have very nicely laid out how important it is to get the data out of the network layer, out of the topology, and that is the foundation. So in principle, the first step is nicely done or is nicely taken with the framework, and then it's relatively, like, say, not easy, but it's easier to add AI and such data analytics tools and everything that's needed on top.
May I very briefly? So I think, in the ideal world, what I see is that the southbound interfaces that VOLTHA and SEBA are offering is already there, because by implication, it's already open. And by implication, we think the richness of the parameters that AI can use to do something with is already there. I'm simplifying. So the challenge then is to get the intelligence, the LLMs, and the return path to then optimize, do whatever clever stuff is going to happen.
Great. One more time for Mahir and for Fran. Thank you. Please, Mahir.